Hey, welcome to Pomodoro Joe for Thursday, October 19th, 2023. Today we're looking at LeetCode problem 844, backspace string compare. Thank goodness this is an easy problem. Yes. Given two strings, s and t, return true if they are equal when both are typed into empty text editors. What does that mean? So it looks like this hashtag character means a backspace character. Note that after backspacing an empty text, the text will continue to be empty. Okay, so we have an example. S is A, B, hash, C, and T is A, D, hash, C. Now, if we use this hash as a backspace, it means we're going to backspace this B and we'll end up with a C for string S. And here we're going to backspace this D, so we'll end up with a C for string T. So yes, S and T both become AC. All right. So this is pretty straightforward. Let's put 25 minutes on the Pomodoro timer and we will get started. All right, so anytime you might want to backtrack or undo something, a good rule of thumb is to use a stack. A stack is just a data structure that is a last in, first out data structure. So that means, like, you can think of it like a stack of books or a stack of coins. You'll put a couple books down, the last one that goes on top is the first one you'll take off when you grab a book off the top of the stack. So we'll use a stack. We'll just go through every character in each of our strings. We'll put them on their own independent stacks. So we'll put every character onto a stack. If we reach a backspace character, then we can just pop that last character out of the stack and throw it away. And we just keep doing that till we get to the end of the string. All right, so let's start with two independent stacks, one for S and one for T. All right, so let's see, we'll have our S stack. And in Python, you can just use a list. So we'll just use a list here. All right, and then for every character in string S, if this character is a hashtag, so if this character is the backspace character, the hash character, well then we'll check to see if we have the stack. So if there's something on our stack, if S stack, well then we'll pop something out of our stack. So S stack dot pop. And we need to pop at -1. That is the end of our stack, or the top of the stack. So if we reach this backspace character and we have something on our stack, we will pop it off the stack. All right. And if we do have a backspace character, at that point we can just continue. Continue just says go back to the top of the loop. So we'll just go through. If we have a regular character, we're going to put that on top of our stack. So if we don't have the backspace character, then our S stack dot append this character. And that should give us the final string, or at least a list of all the characters in our final string. Now we don't actually have to convert this back to a string. We can just compare the two stacks at the end. So we'll do that. And we'll do the same for string T. So let's just grab this whole thing. All right, and instead of S stack, we'll have a T stack. And I'll replace every place that we have S stack, we'll replace with T stack. And at the very end, we just need to compare the two stacks. If they're the same, we return true. If they're different, we return false. So we can just return whether or not our T stack is equal to our S stack. So I'll just do this here. All right, and make sure we change this to string T. All right, so for every character in string S, we'll check for backspace characters, pop things off the stack if we find one. Otherwise, we just append that character to the top of our stack. And then we'll go through string T and do the same. And then we'll compare these two stacks at the end. All right, let's see how we do. Okay, seems to work. Let's see if we pass all the tests. All right, and we pass. And we don't do very well. Let's see, we only beat about 40% for runtime and 20% for memory, so not great. Now we could come back here and try a couple things to speed this up. One thing we could do, since these two things are very similar, basically we're just repeating our code, we could make a little function out of this, and we can do this here. Let's do that. So we'll define some function that's like final stack. And we'll take our string. Actually, I won't call it S, I'll call it I for input. No, what do I call it? I'll call this characters. All right. And then for every C in our characters, so we'll just take this whole thing Actually, I can just do this. Indented there. Instead of calling this S stack, it's just going to be called stack. And for every C in our characters, let's see, this will just be called stack. And then at the end, we will return our stack. All right, and now all we have to do is call this same function with both our T and S inputs. So let's do that. S stack will be equal to this final stack, passing in our string S, and then T stack will be our final stack, passing in string T. All right, so this might save us a little bit because there's less code to parse, although it might take more time because now we have to make these internal function calls. So let's see. It still works. Let's see if it's any faster. Oh, and that's significantly faster. All right, now we're at an 85% for runtime and an 83% for memory. So that is much better. So repackaging our code as a function and then reusing that code is much faster than having two independent codes that are basically copies of the same set of code. Cool. Well, I'm pretty happy with that. Let's see. We could probably do some small things in here to speed this up, but I'm pretty happy with the way this is working. Let's try swapping. I'm just curious. Now we're like off the clock. I want to try swapping this conditional. Let's say if C is not equal to this hashtag, then we'll append the C. And continue. Otherwise, we'll do this. And we don't need this continue. Cool. And then this is not great coding practice, but I'm going to put this on one line. Makes it a little bit more compact. Cool. This is not right. How did that happen? All right, submit this, see how we do. And it looks like we might do a little bit better. We go actually 85% with an 83% for memory, 85% and 54% for memory. So we actually do a little bit worse. Oh well, it was worth a shot. Just thought I'd try that out. Okay, well, I think that is it from me. I hope you enjoyed this. I hope you had fun. I hope you learned something. I hope you can go out and write better code.